welcome all of you. So in this video I am going to take up all important questions of hydrogen chloride, that is HCl gas and HCl acid. Now in this chapter, now here in this, what are the important questions? Okay, I repeat whenever I tell in each of my videos, these are not the only questions, these are the important questions. That is, by no way you should go to the examination without knowing what I am discussing right now. After this, once you know this very well, please go ahead and learn the other, learn all the other equations, everything else in this chapter. Okay, so these are the most important questions based on all previous years questions which they keep on asking every year. So I am taking up this because this is completely based on last 10 to 12 years questions where they have kept on and on repeating. So this is a trend that ICSE is following. So for 2025, let's see the important questions. Okay, now here in this chapter, one very important question keeps coming is what is the funnel arrangement? They are always asking questions on the funnel arrangement. Okay, so you have the funnel arrangement for making, so there you have a beaker and in which there is water, and then there is a funnel where you place the funnel just above the water. You don't stick it to the water. Why? Okay, and what is this? First thing they ask is, what is this process used for? This process is used for preparation of HCl acid from HCl gas. Okay, so this is a must. From HCl, too many equations are not asked. So here, this is when you dissolve HCl acid to HCl gas, you get, when you dissolve HCl gas to water, you get HCl acid. Now in this funnel arrangement, they will keep telling you what is the purpose of this arrangement. Second thing they ask, why is it kept little up and not touched with the water? It is not touched with the water because if you make this funnel touch with the water, there is back suction of water. Okay, back suction of water, little water goes into the funnel and goes up to a level which stops the process. Okay, so you will have to write that due to high solubility of HCl and ammonia are two gases. You have to know some of the properties of these compounds. HCl very soluble, highly soluble in water. Therefore, it easily, all the gases here gets dissolved in water very soon, and there is a vacuum created, and that vacuum is taken up by the water. So that is what is back suction. So in order to stop this, they leave a gap so that no vacuum is created, no back suction happens. Okay, so this is one thing about HCl, one very important question. Another thing that keeps coming, because ICSE chemistry paper has the tendency of asking questions which are which use concepts from different chapters very commonly. So they actually ask questions, is HCl a polar compound or is it not? Okay, yes, HCl is very much a polar compound. Okay, so HCl H plus and plus Cl minus. Here goes in HCl, actually if we draw it like this, then here this is the shared pair of electrons. Okay, and here chlorine has its own other electrons. So this pair of electrons, due to high electronegativity of chlorine, this side gets a negative pole and hydrogen gets a positive pole. These few basic things, this can be asked for from acids bases also, or it can be asked in this chapter also. So these are few questions. What next? What next they can ask? So it is a definitely polar compound. Okay, and so polar compounds polar dissolves in polar. So this is polar because it forms poles and it dissolves in water. Okay, very much soluble in water. Let's talk about another thing that's very important based on the solubility of HCl is the fountain experiment. Fountain experiment you find in two compounds. One is HCl, one is ammonia. Okay, in HCl is a acidic gas. Okay, if I talk about hydrogen chloride gas. Now another thing I want to tell you all here, HCl gas and HCl acid, two different things. Please understand this. Once again, in acids bases also I'll mention. So here HCl gas is in the dry state, here HCl acid, when we dissolve the same gas in water like this, it becomes HCl acid. Okay, now HCl gas is highly soluble and it's an acidic gas. Because on dissolving in water, it is forming acid. So this gas is highly soluble, as I said, and since it is highly soluble in water, now what happens is, in the fountain experiment, which litmus solution will you have to take? You have to take blue litmus. Why? In the fountain experiment, you have a... Now what happens due to the high solubility? What is the fountain experiment? Let us see. So here in this fountain experiment, what happens is, we'll have a beaker which has blue litmus solution. Okay, litmus solution. It has blue litmus solution. And then here we have a round bottomed flask fixed here with a stand. Okay, here we have a pipe, and then which is going down into the solution, and here we have a small dropper, okay, with water. This part is filled up with HCl gas. Okay, here we have HCl gas. Now what happens? The moment we press the dropper, we introduce few drops of water into this jar, into this round bottom flask. What happens? The moment we introduce few drops of water into this, immediately what happens is, due to high solubility, a lot of this gas gets dissolved in this water and comes to the liquid form, so it takes less space. There is a partial vacuum created here. Vacuum is created here. Now what happens? The moment partial vacuum is created, due to the low pressure area, water from here, just like we drink water from a straw, this litmus solution from here goes into this, but then as it goes into it, it comes out as a red solution. Okay, so why it sprays out red? Okay, they can ask a question. Okay, generally they will not ask you to draw diagrams, but what they will say is, they will they will give this experiment and say what is the color of this spray and all that. So color of this spray is red. Okay, why is it red? Because HCl acid was there. Okay, blue litmus solution turns red when it comes in contact with an acid. So here you see a red spray of water suddenly, though the water here was blue. Okay, so this is telling us how highly soluble HCl is in water. Okay, because just a few drops and a lot of gas here gets dissolved in it. Okay, so for HCl gas, actually 1 volume dissolves 452, 1 volume of water will dissolve 452 volumes of HCl gas. Do you understand that? Very simply, you have 1 glass of water that has the capacity to take in 452 volumes of water. That means it can dissolve 452 glasses, the same glass of water. Very simply, that's the meaning of this. Okay, so it's highly soluble. So this is another question that is always asked from this chapter. Okay, so you should not miss that. Now the next question that is asked from HCl is, you will see a whole list of equations. Okay, so you will see with active metals, how does HCl behave, and here it is all dilute HCl. You have to remember it is dilute HCl, and the gas given out, generally they focus on what is the gas given out. The gas given out is hydrogen. Okay, then you have things like ZNO, okay, oxides, CuO. So this actually is a neutralization reaction, and the gas, there is no gas given out, because if it is acid and base reaction, you get salt and water. There is no gas given out. Then you have the carbonates, okay, carbonates and the bicarbonates. You have to remember like this. If you just try to write the equations and try to memorize them, you will not be able to manage. So carbonates and bicarbonates give out carbon dioxide on reaction with dilute HCl. Okay, then you have sulphides, that is SO3, and bisulphite. Okay, sulphides and bisulphite. This is HSO3, this is SO3. SO3, HSO3 radicals. Okay, and they also give out. So you have to take hint from these names. Okay, you have to take hint. Next is sulphides. Okay, sulphides. Now if it is a sulphide, it gives out H2S gas. So what are the four types of gases? What are the four types of gases? We have H2S, H2, CO2, SO2. Okay, these are the four types of gases. They will focus on the tests for these gases also, and they keep asking what is the observation. Okay, so here this is a colorless gas which burns with a pop sound. Okay, H2S is rotten egg smelling gas. Okay, given out here. CO2 turns lime water milky. Okay, so you have to mention the tests. This is a colorless gas, again turning lime water milky, and this has no effect on KMnO4, that is potassium permanganate, or K2Cr2O7 solutions. Okay, come to this sulfur dioxide. This also turns lime water milky just like CO2. Then how do we differentiate? How do we understand that that gas is SO2 or CO2? How do we understand? Okay, now this turns SO2 will turn K2Cr2 K2Cr2O7, that is potassium dichromate, okay, orange to green if it is brought in contact with SO2. KMnO4 will be turned from pink to, it is pink in color, violet pink kind of, okay, to colorless. Pink to colorless with no yellow dots. Okay, so these were few of the tests of the different gases. When they say observation, you'll have to tell it's a colorless gas, or if it is a colored gas, okay, what is the change in color, what you can see comes under observation. So you have to say all those things, and of course naming the gas. So you should remember the gas depending on carbonates give carbon dioxide, sulphides, bisulphites will give sulfur dioxide, sulphides will give hydrogen sulfide, and active metals always give out hydrogen. So you have to learn them in categories, not learn them as names. Okay, apart from this, they ask this AgNO3 plus HCl. Okay, there is a double decomposition reaction, and that is AgCl plus HNO3. Okay, how does HCl react with AgNO3? They'll keep asking. White PPT. Okay, white PPT. They'll also ask the color of the precipitate. So you should tell it is a white PPT. Another question that is often asked is NaCl plus H2SO4. That is the lab method. Okay, we want NaHSO4. Okay, plus HCl. So we want NaHSO4, and the temperature is always kept less than 200 degrees centigrade. Now they will ask you, why should the temperature be kept less than 200 and why not more than 200? And you have to tell that if we keep it above 200, then Na2SO4 is formed, that is sodium sulfate. Here this is an acid salt, this is a normal salt. So sodium sulfate is formed, and then what happens? If sodium sulfate is formed, this salt is firstly you waste fuel. Okay, you are wasting fuel because of high temperature. Second thing is, this is a sticky, okay, it forms a sticky substance which sticks to the base of the apparatus, making it difficult to remove. Okay, so why go through all that when you can manage with a lower temperature? Okay, so this is one question, why is the temperature not increased to more than 200? Okay, that always comes. Here another question keeps coming, why do we use H2SO4 to dry and not CaO or P2O5? Because these two are also drying agents. Okay, phosphorus pentoxide or calcium oxide, these are also drying agents. Then why H2SO4 is used? Because if we are using HCl here, this HCl, we are trying to dry HCl, it will react with it. Okay, so we don't want our product to react with something else and get over. So we are using this because it takes away only the water vapor that comes along with it and does not react with the acid. That is why H2SO4 is used. So you have to tell, though this is a drying agent, these two, they react with HCl, so we don't want that. They react forming respective chlorides. Okay, so you'll have to tell that they react with it, they react with HCl forming respective chlorides, and we don't want them, the product, to react with the drying agent, right? So we'll be using this. Okay, so these were few of the questions that have high probability of being asked in the boards, generally repeated every year. So see to it that you know these things before you go to the examination hall. Other than this, you learn few of the uses of HCl gases, okay, and the general properties of HCl, how you collect it in the lab method. So this is, you should know it is collected by upward displacement of air, means it is heavier than air. Okay, so that is it from HCl important questions. If you have liked the video, keep following for more videos. Please subscribe the video. Okay, you'll find lots of other videos in physics and maths in the playlists. Okay then.